Hello YouTube, RJ. Hey, in this second part of looking at the 3400 AHP true RMS meter, we're going to pick up where I went in and started a calibration procedure and went through the whole calibration procedure, and we're going to see how we came out, and we're going to give it a little test. We're going to see if this does what we want. And so I'm going to jump into the continuing video where we had to leave off last time. Okay, so here's what I did. I went ahead and walked through the calibration procedures in the manual, and it has really good manual, and you have to walk through each step, and then you have to go back and check, and then go back through this back and do a couple more steps, and you keep doing this. And it's a little bit tedious to be very precision with it. I spent probably 2 hours, and I'm very happy with the outcome. I was able to get the meter to read very accurate. So what I've got is I'm going to give you a little demonstration now that I went through the procedures. It's just a case of the meter hadn't been calibrated in years and years and years, and everything drifts. We know that. So here's what I've got. I've got my signal generator set up again, 400 megahertz. Got it set up to put 1 millivolt RMS out. So let's put 1 millivolt into it. Okay. And let's go to the millivolt range. And as you can see, I'm getting full scale. It's reading a millivolt. If I go to 0.9 millivolts, it's reading 0.9 millivolts. So let's do this. Let's go up and scale a little. Let's go to 3 millivolts. And it's 3 millivolts, right on the money. So, I mean, it's doing what it's supposed to be doing. So let's jump up to 100 millivolts. You got 100 millivolts. Let's go to 300 millivolts. And we're reading 300 millivolts. Let's go up to 1 volt. And you're reading 1 volt. We want to read 0.8 volts. We read 0.8 volts. We can go up to 3 volts. You're always supposed to go up in range beyond what you're going to do and change, because it slams the meter around. Otherwise, it's not good for it. 3 volts. And I don't think I can get 10 volts out of this. Let's see if we can get 10 volts. No. 3.535 is the most I can get, which dead on. I mean, you couldn't get any better than that. That is so close to being dead on. Very happy with that. Let's look at 3 volts again. It's almost the maximum what I can do. There's 3 volts. 2.5. It'll pretty well nail it. And it did. So I'm very happy. I mean, this thing is not that much younger than I am, and still works this well. Cleaned up nice, I think. Very happy. Now, if I want to hook up a radio and look at a noise figure, we can do that without guessing. In fact, why don't we do that? Let's close the video out with, let's actually try this thing out for the reason that I wanted it. Let me hook up the Lynx Easy receiver real quick, terminate it, and let's see what kind of reading we get for noise. Give me a minute, I'll be right back. Okay, we've got the Lynx Easy shortwave receiver hooked up. I've got it terminated with a 50 ohm terminator. I'm clipped onto the headset output again, and it looks like I'm reading about 8.5 millivolts of RMS, which I think is in the ballpark of what I guessed on the oscilloscope, but it was kind of guessing, and you don't want to be guessing in a lab. So that's That's where this comes in. This gives me a good solid. You can see the needle's pretty stable, barely wobbles because of course the noise is bouncing a little, but I've got a average RMS of about 8.5 millivolts. So let me jump right over. I'm going to hook the R10 back up again, do the exact same test. Let's see how it came out. If it showed that massively higher noise that we saw in my previous reading, and you know we'll verify that. So I'll be right back. Okay, there you are. I got the lights off to get rid of any noise. Didn't do that with the Lynx, forgot to do that with the Lynx receiver. Probably would have dropped the noise floor a little bit. As you can see, where we were looking at, 8.5 millivolts down here on the 10 millivolt scale, we've had to come up 30 times higher scale. And we're reading in the neighborhood on the 0.3 scale, we're reading about 100 and, I don't know, 125. Yeah, 125 millivolts, bumping sometimes towards 150 millivolts noise. Yes, there is a dramatic difference in the noise floor between those two receivers. And that's going to be because there's a lot of amplification in this little receiver here trying to get weak signals. There you go. I hope this was interesting. Kind of neat to look at an old technology meter. Appreciate you tuning in. Appreciate you hanging in here with me. Hope you learned a little something. Hope you found it entertaining, and really enjoy having a new meter in the lab. So next time we need a noise RMS noise reading or any reliable stable RMS reading, we got the meter to do it. Hope to catch you in the next video.